In regard to the unit circle, the radian is the measurement of the outside of the circle, and the degree is the measurement of the triangle's angles on the inside of the circle. We must use the 30, 40, 60 degree reference points for degrees because the special triangles 45, 45, 90 and special triangle 30, 60, 90 because if any other degrees would change the hypotenuse and height lengths. Radians are better to use because they cover more distance compared to all the degree angle points.
Alright, converting radians into degrees and degrees into radians is easy by just using the pi over 180 method, where pi is equal to the radians and 180 is equal to the degrees. So first off, I'm going to give an example equation, which is, obviously you take your pi over 180 and set it equal to, let's use 3 pi over 4 over x. So right now we're going to convert radians into degrees, which degrees is our x, unknown variable. So you got to cross multiply, and we're going to end up with pi x is equal to 3 pi over 4 times 180. So I'm going to leave it like that right now, but that is actually equal to 424.115 as a rounded number. So now you want to take this and divide it by pi to get x alone, and that leaves us with x is equal to, and you plug this into your calculator, and I got 135 degrees. So now we changed our radians into degrees, and I'm just going to go ahead and quickly change that back so that you can go from radians to degrees and degrees to radians. So you take the same equation, pi over 180, and you set it equal to x is now on the top for our unknown variable, and I set my 135 degrees down at the bottom. I'm going to cross multiply just like last time. Now I got 135 pi is equal to 180x. So I'm going to divide 180 from both sides. And this right here can be simplified down by 45 on each one. And it brings us back to 3 pi over 4 equals x. Changing our radians from degrees and degrees back into radians. Boom.
We chose the problem of jumping on a trampoline as to where me hitting the bottom of the trampoline before depressing is our ground, and jumping up in the air after depressing is the max height. For this problem, we chose a phase shift of -3 so that we could move the graph over to the right 3 to be able to use cosine starting at the top of our graph going down. Our period in this graph is 6 seconds from top height to top height, from where I reach my max height on my jump to the very next time that I reach my max height. Our sinusoidal axis is the middle of our graph, which is the max height plus the lowest depression added together and divided by 2, which is 2. And our amplitude is from our sinusoidal axis to the top max height that I reach after a jump, and that reaches 3. So we use cosine because we are starting from the top and going back down.
Alright, so our equation is written down below, matched up with our graph, taken where 2 is the sinusoidal axis that you plug in, 3 is our amplitude that we plug in, 6 ends up being our period, the seconds in between, and 3 we plug in for our phase shift so that we can end up with cosine. So here's a problem that we made. At what height would Trey be at during the 5th second of jumping? So what we're going to do is we're going to take y equals 2 plus 3 cosine, double parentheses, 2 pi over 6. And then you're going to input that for x, 5 minus 3. Alright, now Aiden hand me my calculator. Thank you. Alright, after putting in your calculator, I'm going to make sure that I have my parentheses correct because they're going to be a couple double parentheses. And after checking it, y equals 0.5. So at my 5th second of jumping, I'm going to be 0.5 feet off the ground.
As you can see, at 5 seconds, it matches up pretty well at 0.5 height. Thank you for watching.